Welcome everyone. Thank you for coming on down. I know it's 10:30 after a concert night, so we're all a little bit groggy. I feel for you because I'm in the same position. But I want to thank you for coming on down, and we're going to talk about how I was able to build a full-size CNC for under $500. Kind of that catchy, draw you in title. So a little bit about me. I'm from Akron, Ohio. I pretty much lived in northeastern Ohio. I'm a hobbyist with woodworking, and I got a metal garage. Worked at local maker spaces. Familiar with these technologies, and spent time at the University of Akron for computer and electrical engineering. One of the key driving factors for this whole project was the third bullet point, husband. $500 is the price point mark where you can kind of get adoption from the spouse without them talking about divorce proceedings. Of course, father, want to spend time with my kid and enjoy that time. And interesting enough, the CNC project has been able to kind of lend towards that. I'm a member of the Northeast Ohio Information Security Forum, which is a cybersecurity community. And you can find me on Keybase, and of course, all my views are my own. So what I really wanted to start this whole project was a CNC router that could handle a full sheet of plywood and be low cost. And that seems pretty impossible when you're looking around, because you immediately start talking about your stepper motors or your servos, and you already lost half your cost right there. And then if you talk about any sort of linear guides or any of those other aspects, you're way out of budget. So I wanted to choose full-size plywood because if you're looking to build a main cabinet or start any sort of project, you usually begin on how can I best cut up the raw materials that I've got, and one of those raw materials is, of course, plywood. So when I was doing some searching around and spent a lot of time on this, what I found was there's a couple of different options. One of them is, of course, ShopBot, which handles all the conditions except for cost. It costs $18,000 to get yourself into a 4x8 sheet cutter. Obviously, it can do a lot more than this project could, but it's still way out of my price range. Next is another cool product which is just coming out. It's called Shaper. It's actually a portable CNC handheld device which augments the movement as you bring it around. It uses fiduciary tape. Kind of cool, but again, it's still around $1,800 to $2,000. You could do a used DIY project. Sometimes you can find people who are upgrading and going from a 2x4 or a 4x4 system and going up to a full-size ShopBot or something of that like that. But you're still, like, again, $2,000. You're not going to really find them around too easy. And of course, the all-knowing X-Carve or Shapeoko, pretty much the same generic design, but they have a small workspace and they're still about $1,000. So when I was looking around, I did find one other interesting project that just kind of came on the scene earlier this year, and that was actually Maslow. And Maslow was a Kickstarter project, and unfortunately I missed the Kickstarter phase, but the cost was reported to be between $300 and $500 for the final product. It was open source, which I always like because I want to contribute back to the community and help other people grow. It has a dynamic workspace. Now that was pretty interesting to me when I was looking at the conditions. Is how can it have a dynamic workspace but still promise on this particular price? And I'll get more into that. And of course, it has a smaller footprint than most. And it didn't make sense to me. How would you have smaller footprint and still be able to use large, full-scale size items? And the interesting way that that was handled by one of the developers was to invert the workspace and set it on an angle. You do that, now you're using gravity to assist with your cutting mechanism. Your platen is pushed down on the work surface, and a couple of bricks or weights or whatever else you try to kind of choose to hold down that product, and chains, simple roller chains and motors, would take care of it and hold that the router down to be able to cut most projects you're looking for. Well, that was pretty awesome. The couple of the issues that were coming with the product was that you had to have calibration, and the speed was slow. Quarter-inch cuts with only 30 inches per minute, and standard 12,000 RPM for a router. It had some accuracy issues in the corners, but those accuracy issues actually were only 30-second at the far edge. And if you guys are doing anything with woodwork, you know the 30-second is well within, you know, fudge distance. You don't care about that sort of, and that's exclusively on the edge. And it couldn't do metal, because you're not going to be able to do any sort of major plunge cuts with this router while it's you're leveraging gravity to make the cut. So you're kind of accepting those aspects. But if you know anything about hobbying, you know that you can do templates, and with a wooden template, you can use that to then cut metal and you know, carve out particular designs you're looking for. Now, missing the Kickstarter phase was, you know, kind of a blow. I wanted to get into this project and wanted to help begin this, and unfortunately, there was a few items that were on the build that you just couldn't get anywhere else. And I always remember all we need is a little plutonium from Back to the Future. You know, you can't just go around and pick that up from any old corner store. So part of the project, we was open source, which is always a score, and then we had an open BOM for both mechanicals and electricals, along with all of the source code necessary to run this devices. So I started going through and looking at the electricals, and you know, it's pretty simple: a power jack, a connector, header pins, yada yada yada, all the way down. It runs on an Arduino, which seemed pretty good. The board was available via Gerber files, which you can send to any sort of manufacturing house, and of course, getting parts from eBay wasn't an issue, and getting them all in all real quick. So that's no problem. And when I go through the mechanical BOM, I see a few things that are on there which, you know, make sense. We need plywood, and we need drywall, and then we get down to some of the heart of it, which is our motors. And the motors, you can't really get anywhere. And the motors are kind of interesting because the way that they're handling this whole project, instead of using stepper motors to know the position, it requires you to go ahead and have a gearbox with a worm gear, specified at 30 kilograms per centimeter of torque, and around 20 inches per minute, and 12 volts, which all makes sense. But you need to have this in a particular package that can then be run by your H-bridge from the electrical side. So you couldn't just go out and grab any old, you know, universal motor and hook it up and expect it to all of this to work. So there's several iterations of looking for where they acquired this manufacturer, because they didn't want to really let people know. I was able to find it on Alibaba. So I contacted Alibaba and I talked to them and said, hey, you know, I'm really interested in trying to get this product. I want to do this. I know you missed the Kickstarter phase. And I'm like, sorry, we don't sell to customers. We're kind of a business to business sellers. So I went around and put on my business owner hat and spoke to them, and was able to get appropriate things to work out quite nicely. And I can talk to you more about that offline if you're interested in how that kind of worked. So some of the design considerations for this this build was, of course, exchanging out the linear bearings and screw threads for roller chain. Now, roller chain is pretty cheap. It has a high tensile strength, and you know, work quite well in this particular environment. 12-volt motors with encoders replace stepper motors, which gives you the added benefit that now you have a closed system versus an open system. So at all times, the brains of the operation are able to know the exact position of where that particular works from. So the control path works from ground control, which is the control that runs on a Python script that runs on your computer, talks to the Arduino using the serial bus, and then from there that runs your H bridges, handles your motors, and at the same time the encoders are passing back that data and sending it back to the Arduino, where ground control can then make adjustments to the position as it's working around. Assembly was pretty easily. Didn't require many tools that most of us wouldn't have. A soldering iron, needle nose pliers if you don't have crimpers, Allen, I spelled Allen wrong, keys, saw, and of course a drill with a drill bits and drive. You don't even have to have power tools for these things. You could do these, you know, mostly manual. The electronics, again, were pretty basic. It's a bridge that it's a shield that sits on top of an Arduino. It has surface mount and through-hole soldering. You can available on the Git. You can run Git pull on the GitHub firmware to pull down the Gerber files and then send that off to any particular shop you want. The cost is, again, all included in this point. But you then upload the Arduino, put it with IDE onto the Arduino Mega, put the shield on top, and bam, you have most of your electronics already wrapped up. If you aren't into surface mounted designs, they have recently, and this is just within the past couple months, they've given the option where you can purchase this board. Is now available from stores, about $30 plus shipping costs. If you were to build it yourself, it comes in about $25. So if your time is worth it that you don't want to assemble that, you can go ahead and order it online. So part of the design includes building a temporary frame. We actually use part of the router's design in order to assemble the rest of the router. And we work from an inaccurate machine and then use the inaccuracy of the design to then work up to a more accurate machine. So we take 2 sheets of plywood, 3/4 inch, about $50 each at most of these stores, and 4 10-foot pieces of 2x4s. We then mount them on the plywood on the rear side with just basic screws, letting them stick out about approximately 45 degrees, and then mounting a piece of additional plywood on the side on one of the arms, and then putting a mount on there. At that point, we've got a odd-looking configuration that looks somewhat like the original product that we were looking to get to, but we move forward with putting on the motors, applying a chain, and we leverage elastic cord, which keeps tension on the rear of the chain. This isn't really to pick up or reduce weight from the motor itself, the router that's being moved, but rather to make sure that the teeth of the sprocket engage with the chain and remain engaged, rather than it possibly losing a tooth and losing an accuracy. And that's what this string pulled down and back up is. We take a temporary sled using a simple 4x8 sheet of paper, 8x11 sheet of paper, plopping that down, drilling a couple holes, cutting that out, and then we've got our sled, which we would mount the router to, along with a couple angle brackets that we've mounted through, and then hook up chain. So pretty darn simple. I mean, you can do this in an afternoon, and have yourself a temporary design. The next thing is we install ground control. I mentioned that ground control is the application that's been designed to handle the kinematics of the G-code that you might be loading into it. Instead of using XY positions for a particular CNC router that you might leverage with Mach 4 or Linux CNC, you need to use something else that can handle the trapezoidal shape that this particular setup is going to use. So there's a portable install for Windows. You can also use a git pull. There's a couple Python requirements. It is running on Python 2.7, but there's a push to move it to 3. There were just some dependencies and some inflexibility, some of the options that were built in there. You then calibrate the machine. The calibration is pretty darn simple. It's like a next, straight on through. It shows you images on how to do each one. And really what it needs to know is you need to know the exact position between each motor. So you know one part of the upper portion of the trapezoid. You also need the lower portion of the trapezoid, knowing between the 2 mounting points on the sled. And then, of course, you need to know the center point of the lower edge of the trapezoid to the center bit. So that way, as you move the bit across the platen, you can know the exact location to cut. The next step in the build is you to go ahead and cut with G-code. If you're not familiar with CNC work, G-code is the instructions that are passed to usually the CNC that tells it the positions to meet at what particular times, at what particular speeds, and work the operations. So part of this design, you're building a brand new sled, you're building nice arms, you're building gussets for the rear mounts for the back of it. And of course, you can adjust any of these as you kind of see fit. The workflow through design is similar to any other CNC operation. You're creating it with CAD. You can use Fusion 360 or SketchUp or AutoCAD or any other CAD devices. You then work it through a CAM. If you're not familiar with CAM, that is computer-aided manufacturing. That's where you decide your tooling, your tool paths, the operations that you want to perform, whether you want to have a pocket or you want to have an edge cut or whatever you'd like to do. And that's done with either MakerCam, which is an online website you can perform that on, or Aspire, VCarve, or even Fusion 360 has a CAM operations that are available on it. And then you take that will generate the G code, like I had mentioned. You bring that to ground control, which is similar to like Mach 3 or 4 or Linux CNC, and those execute the movements that are created. So when all of our parts are cut, you know, it's kind of laying all out. It looks like a big mess, but we start assembling here by building the final legs. I mentioned about the gussets being attached to the sides, and those are actually in the G code. In the designs that are available right now. Once you generate G code, you'll see that it'll actually include cutouts for 1, 2, and 3. You can ignore those if you'd like. You then attach it to the legs using a simple block system, where the weight is carried on the top, small 2x4. You attach the arms. These particular designs, we've got a cutout in the corner, permits you to have that at a 45-degree angle without, you know, messing that location up. Attaching those to the rear that you did. And then you create some finishing touches. You use a round over bit on your sled to be able to make sure it doesn't get caught as it's moving across the surface that you're cutting out. And from there you have a built machine. Now there's a couple of issues with this design as I started working through it, and that is that you've got issues of rotation of the sled. And if the sled decides, and since you're using a trapezoidal shape, if the sled decides to rotate to it, well, now you've changed all of your kinematics, and you're not getting to the exact position because you're not having from the center point of that particular trapezoid. The sled can get caught if you're cutting too many depths down as you're working through in your Z. If the sled it gets caught or shifted a little bit, you're going to have a problem there. It's slow. You know, it'd be a lot faster for you if you had a full-size shop bot or something like that, because you can't just plow your router through the material you're trying to cut, because it does need to evacuate those chips. And in this design, it uses a manual Z. So every time you want to make a depth down another 1/4 inch, you need to adjust it and then begin the next cut. There is an option to be able to add on a manual Z, but I don't have the I haven't located all of the parts yet for that bomb to be able to build and have it attached. So some new ideas that are kind of coming out with that is that there's new code that's always being created. If you're interested in getting on that, the spindle control is something that could be added in the future to be able to turn on the spindle and turn off the spindle. Updated power controls with better thermal designs. I'm working on a board design that leverages H-bridges that support a higher amperage and therefore will have better thermal characteristics. There's been some people reporting issues with the current H-bridge warming up, especially like in uncooled environments. And then newer kinematics. The kinematics currently, again, use a trapezoidal shape, but if you're able to have the chains attached to the center point of the router, the actual router bit, the math becomes far simpler and you have far less complexity of calibration. And the way that people are working out that is a series of linked arms, which maintain the position from the sled, or leveraging a hoop that goes around the whole sled with pulleys that allow the sled to be continually, the chains are always directly attached to, or linking to the center of where the bit exists. So all said and done, I tallied up all of the costs that I had and went through all of my receipts as I was working on this project, and everything came up to $498.08. So definitely under our $500 mark. And the nice thing is, that leaves enough money in there for a $2 PBR. The router is included in the price, which was, if you can make it building your own, you don't have to purchase this particular router. You could purchase your own. You need to work up how you're going to attach it. But there's nothing special about this rigid router except for the flexibility that it offers when adjusting for Z. And, this does not include the Z control, but that can be added. Those are available, when they start having the parts available, they're going to be like $60. But if you follow me on Twitter, I'll link out when the next build is available, and I'll find those parts. If you're looking for other resources, all this bunch of this information is available on Maslow CNC, the forums of Maslow, and of course the GitHub there. I know this is a lot of information, and seems kind of complicated, but yes, you can even have a CNC router in your garage, taking up less space than your car, and for under $500. So with that in mind, is there any questions that I can answer for people? Yeah.
So since it's at an angle, nearly vertical, using gravity assist and all that, I'm looking just at the design for the parts that you were cutting out. There. Do they just fall off, or they just drop down? How do you keep from getting in the way if it is trying to progress on the next thing as the part gets created once it's slide down?
You're attaching those either double-sided tape. That's a great question. You're asking about, like, as you start to cut away from the material and you've removed a particular part, how do you prevent it from just falling off? Great question. Tabs is one of the ways. As you're cutting away from a perimeter of a part, you leave certain sections in there, and that's available in most cam designs, where you don't go all the way to the base of that. And so as you come through it, you can lift the bit and move on. That way, when the part is completely finished, you then come through with like a multi-tool or small little coping saw and able to cut that particular part out and remove it. Another way, if you're not interested in doing that, is double-sided tape. Or if you know the position of where that particular part is, you can also affix it with a quick nail gun, and that part would come off pretty simple if you just put a pry bar underneath it and pull it off. So, great question. Anyone else?
What'd you say your depth, the average depth of cut was?
It's a 1/4 inch. So, not huge, but if you're talking about building things from plywood, 3/4, you're 3 passes, and that takes care of it. The most difficult is when you talk about putting in the tabs. You do need to go back through and adjust over each tab, or don't, by doing another method if that's what you prefer. Any other questions? Well, thanks so much for coming out and listening to me rant about something that's not, I guess, InfoSec. So.